Hi everyone. In this video, we are going to look at converting units of volume. This is something that you're going to have to do on your homework in several different places, and it is something that is perhaps not intuitively obvious for folks. So I wanted to make a video to help explain how you do this. So we're going to look at converting units of volume, which again is perhaps not as straightforward as you might think. Now the example that I'm going to be using is a sample exercise that's in your book. It's sample exercise 1.11. So again, you can follow along with what's happening in the book if that's at all helpful for you. Now in this problem, we're told that Earth's oceans contain, oceans plural, Earth's oceans contain approximately 1.36 times 10 to the 9th kilometers cubed of water. Heck of a lot of water. We want to know the volume in liters. All right, so we need to convert between two units of volume. Now, this is perhaps, again, not as straightforward as we might think. If we were to look in the back of the book to see relationships between, volume listed between liters and gallons, and also converting over to thinking about kilometers cubed or meters cubed, what we'd find is a couple different ways to write liters, a couple different conversion factors between liters and forms of meters cubed. You'll see in the book 1 liter is equivalent to 1 times 10 to the minus third meter cubed, or 1 decimeter cubed, or 10 to the third centimeters cubed, or, then there's more about quarts, etc., etc. We don't have a direct conversion between kilometers cubed and liters. So at first glance, you might think that this is a really super difficult problem. There's no way that we can attack this, but we definitely can. We can go from kilometers cubed and find our way to liters. So I'll show you how to do that. First thing we need to do, we've got all of these guys listed. Let's see if we can put kilometers cubed in the form of one of these guys. Now, there's all different kinds of ways that you can do this. I'm going to go with what I think is the most straightforward way for me. Your book, I believe, in this problem and solving this problem does it a little bit differently. So look at how they do it as well. I'll just show you how I do it. So again, anytime we're doing a conversion, we start off with writing down the number that we're trying to convert. 1 times 10 to the 9th kilometers cubed. Now, whatever else happens, I need to get this from kilometers into meters cubed somehow. So what I'm going to do is write a conversion between kilometers and meters. I can do that. I might not know the conversion from kilometers cubed to meters cubed, but I do know the conversion from just straightforward kilometers to meters. I know based on the prefix kilo that 1 kilometer contains 1,000 meters. All right. Now, and this is why it's so important to write down your units when you're doing these things. If you were to just follow the yellow brick unit with this example, you would notice, okay, kilometers cancels out. One of these kilometers would cancel out, and we'd be left with kilometers squared on the top. That would not be good. We don't want kilometers squared in our answer. So what we need to do is convert this value so that kilometers cubed is on the bottom, and it will cancel out properly. So I can do this very simply. I just cube it. Great. So I've cubed kilometers. The important thing to remember here is that if you cube a unit or square a unit, whatever you do to the unit, you have to do to the number associated with the unit. So I've cubed my unit. I have to cube my number. Now, in this case, 1 cubed is just going to be 1, so it's not that big of a deal. But it will become important when we start looking at the numerator in this conversion factor. Whatever, and again, like you cube the unit, cube the number, whatever you're doing down here to the denominator, you have to also do to the numerator. We cubed this unit, we have to cube this one as well. Cube meters, cube the number associated with the unit. That's a point that a lot of people forget. All right, we cube the unit, cube the number, cube the unit, cube the number. Great. So now we've got kilometers cubed canceling out. Great. We're on to meters cubed. Wonderful. Now, if we want, we can go directly, since we've got this conversion here, we can go directly from meters cubed to liters. Great. 1 times 10 to the negative third meters cubed. You don't really have to write the 1, it's just kind of habit of mine. So meters cubed over 1 liter. Meters cubed cancels out. Great. So let's think now about how we can even solve this problem without using a calculator, right? This essentially, 1,000 is essentially 10 to the third, right? So when we raise an exponent to an exponent, we multiply the exponents together, giving us 10 to the 9th. Now we're multiplying these together, but since we're not raising this to a power, we add the exponents. So this gives us 10 to the 18th. Now when we go here, we're dividing by an exponent, so we would subtract. When we subtract a negative 3, we end up adding 3. So we end up with 10 to the 21st for our exponent. And since this number is essentially just being multiplied by, divided by 1, multiplied by 1, it stays the same. 1.36 times 10 to the 21st liters. If you remember that whatever you do to the unit, you have to do to the number, I think these problems will be very straightforward for you.